all the presence. We're going to introduce the project FM radio transmitter. The members are Denise Perez and Jennifer Beltran, and we're for the parallel number 1. And our teacher is the master David Baca. So, in the communications, there are two important signals involved in establishing a proper communication system: wave carrier and modulate signal, the signal message. To transmit analog signals, their carrier wave can be modulated using the amplitude modulation or AM, frequency modulation or FM, or phase modulation PM. An FM transmission is a process to encode data using modulated signals, which keep its amplitude constant, but its frequency could change depending on the variation of the amplitude and of the modulation wave. Mirror signals introduce a voltage in the receiving antenna. The receiver amplifier the signal, sends the signals through a limiter and discriminator, and reproduce the information transmitted at the receiver output. As shown, you can see here, the limiter or discriminator cuts the carrier up and down to eliminate variation in amplitude. The unwanted signals cause a variation in the carrier of the receiver in amplitude of the receiving antenna. This will not appear at the receiver's output since they are not varying the frequency of the carrier receiver. This is because the FM transmitter is essential, free of interference and noise with respect to the amplitude modulated carrier. So now we are introducing a swing tank circuit. What is this? LC oscillators are oscillator circuits that use an LC tank circuit from the components that determine the frequency. The operator of the tank circuit involves an exchange of energy between kinetics and potentials.
In general, an FM transmitter requires components as a microphone, an audio port, a modulator, an oscillator, an RF amplifier, and antenna. For this project, we will focus on the oscillators. A tank circuit is an electronic circuit used in many applications, including oscillators, radio, and television sets. This circuit consists of two components, capacitors and inductors. These two are connected in parallel to create a circuit now extant. In addition, the name tank comes in fact that this current store energy.
LC oscillators include the Hartley and the Colpitts oscillators. So, the operating frequency of a tank circuit LC is simply the resonant frequency of the parallel LC network, and the bandwidth is a function in the circuit code. Mathematically, the resonance frequency of an LC tank circuit with a code with 10 is this mathematical equation.
It is possible to use an oscillating tank circuit from AM transmissions. Well, and means amplitude modulation and transmission consists of a constant frequency carrier wave generated by an oscillator. The wave to be transmitted a sample signals captured by microphone. The combination of two signals modulations transmitted by antenna. Therefore, it is possible to use a circuit mounted in a complex configuration from a transmission. Application of a tank circuit. The circuit has multiple applications. A mount is made once we have the radio. When you tune your radio to your favorite stations. The 10 circuit inside the radio is able to tune an aerobics band, and the audio signal is traded from it. So the only things you hear the music that come out of that station. The same applies to tune in different channels on television. In addition to the communications industry, so has mobile phones. Well, I hope you have understood, and thanks for watching.